Because this function is a polynomial, it automatically satisfies the continuity and differentiability conditions that we need for mean value theorem to work. So because of that, we're ready to go. We don't need to worry about this last condition because that's for Rolle's theorem only. So what do I do now? I need to find the value of the function at its endpoint. So at f of negative 2 and f of 1. F of negative 2, when I plug that in, I get negative 2 cubed is negative 8, times negative 1 is positive 8, 2 minus negative 2 is 2 plus 2, plus 8 would be 12. And when I plug in 1, I get 2 minus 1, which is 0. Okay, now I need to find what I get when I basically find the slope of the line connecting these points. So I have 2 points. One of them is negative 2, 12, and one of them is 1, 0. What is the slope? I'm going to do 12 minus 0 divided by negative 2 minus 1. This is going to give me 12 divided by negative 3 or negative 4. Okay, now that I have this value, I'm going to take my derivative of this function and set it equal to negative 4 and then solve. So what's the derivative of this function? F prime of x equals negative 1 minus 3x squared. Remember, I'm going to set this equal to negative 4 and then solve. In order to do that, I'm going to add 1 to both sides, so I get negative 3x squared equals negative 3. Divide both sides by negative 3 to get x squared equals 1. And when I take the square root of both sides, I get x equals plus or minus 1. Be very careful because only one of these values can work. Because x equals 1 is on the endpoint of the interval, and that's not allowed. The x value you're ever going to use for mean value theorem has to be between the two numbers on the interval. So we cannot use x equals 1. We have to use x equals negative 1, and this is our answer.